Hey, this is a problem some students have been asking about, so I just thought I'd do a little video here. It's from webassign. It's section 7.3 using the shell method, and they give you a region. The top of the region is traced out by y equals 1 over x. Then there's x equals 5, x equals 6, and y is 0. And we want to rotate this thing about the x-axis using the shell method. First, note it's much easier to do the disk method here, but they want to kind of nail it into your brain that you wouldn't choose the shell method. Don't do it this way. But if you have to, you have to. So let's go ahead and take a look. So the problem with this is that there's two regions to deal with. This first region right here, this box, so this region here, and then there's a second region on top, and it's different because that first region is not variable. And a matter of fact, you can literally just use geometry to figure out the volume of the resulting rotation, right? It's just pi r squared h, r squared h. The radius is 1/6, so you get pi times 1/6 squared, and then the height is just 1. Okay, so you should get pi over 36 for that first region after you rotate it. So when you do rotate it, and we're in the shell sort of category right now. So in the shell category, you are dealing with parallel, right? So parallel rectangles like this. For shell, you need two pieces of information. You need basically the radius, which will just be given by y, and then you need the height of the shell, which in this case it's always going to be 1. Okay, so if you were to rotate this thing, the resulting shell for that particular little rectangle would be this object. Okay. For that one, and then what you're going to do is just sum up a bunch of these things, and it would end up giving you this overall object. But the overall object is just, at this point, it's just a kind of a smush cylinder is what I'm saying. So anyways, you need those two pieces of information. You need this piece of information, which is height, and then you need this other piece of information, which is the radius. And yeah, so the radius is just going to be y. So for this region 1, we'll say the radius, which we're calling p or rho, is just going to be y. And then for the height function, it's constant in this case. No matter where you put that rectangle in this first region, it's always going to have the same, it's always going to have the same height. So it's 1. It's basically the height is 1. It's this width down here. 6 minus 5 is just 1. Okay, so that's the first region, and you could do the integral for that to find that part of the volume of the object. So that's just the integral from 0 to 1/6. You got a 2 pi and then y times 1 dy. So that's going to be 2 pi y squared over 2, evaluated from 0 to 1/6. The 2's cancel, of course. You get pi y squared from 0 to 1/6, and then of course that's just going to be pi over 36, which is kind of what we thought it was going to be anyways. Okay, the troublemaker then is this other region, this region 2, and the issue is now the height is variable. And what is it dependent on? It's dependent on that original function y equals 1 over x, kind of, right? So let's go over here and set up region 2. Okay, so the formula for the radius is still just going to be y sub I. So for that particular rectangle located here on this picture, that's just going to be y sub I. So again, we could just say that p of y is going to be y. So we're left with figuring out h of y. So h of y is the height of that little blue rectangle, and you could think of it as a difference, right? So the distance, there's two distances involved. There's this long distance to the actual function, and then you're subtracting away this shorter distance to the location, 5, right? So it's minus this, and that's it's not like this is minus. It's this height minus this height. So the first height here, the first rectangle, is given by this function, but you have to put it in terms of y. Right, so it's actually x equals 1 over y. You just cross multiply and solve for x. So that's this function, or this length, for any position y. The distance from this position all the way up to the top of the rectangle is 1 over y. Okay, and then the other distance from the y-axis all the way to the bottom now of this rectangle, that distance is constant throughout the second region, and that distance is just 5. Okay, so when I think of my height, it's not just going to be 1 over y, it's going to be 1 over y minus that distance of 5. Okay. Okay, and then that's really it. That gives you the second integral. Expand this a little bit so I have a little bit more room. And 2 pi integral y times 1 over y minus 5 dy. And it's going to go from where to where? It's going to go from where this previous integral left off at 1/6, and then it'll go up to 1/5. Okay, and I base the 1/5 and the 1/6 off the function. So when x is 5, y will be 1 over 5, right? When x is 6, y will be 1 over 6. And that's just from that original function, y equals 1 over x. Okay, so anyways, getting back to this integral, let's go ahead and distribute the y. So you get y minus 5y dy. And then you're going to get 2 pi times... y times 1 over y is just 1. Sorry. So then you get y minus 5y squared over 2 from 1/6 to 1/5, which is annoying, but we'll deal with it. If you want to get rid of that fraction, distribute the 2 from the front, so you get pi times 2y minus 5y squared. I don't know how much that's going to help, but anyways, there it is. Then we're going to use fundamental theorem of calculus to evaluate. So I have pi times 2 over 6, which is the same as 1 over 3, minus 5 36s, and then minus this thing evaluated at 1/6. So I get, they're not both 1/6. The first one is 1/5. Okay, I'll change things. I'll try that again. So the first guy, 2/5, and then 5 times 1 over 5 squared is just 1/5. Minus, put in 1/6, so I get 2/6 minus 5 over 36. It's a little bit of arithmetic now. So that will be 2/5 minus 1/5 is 1/5. And then minus, let's find a common denominator here, so 6 top and bottom, so I have 12 36s plus 5 36s. That'll be 1/5 minus 7 36s. Ugh, what an annoyance, huh? Let's see if there's anything I could do to alleviate the pain of what's coming. I think we're kind of stuck with this. I'm hoping I made a mistake or something, but I don't know. So anyways, common denominator, multiply top and bottom here by 36, unfortunately. top and bottom here by 5, unfortunately. So you're going to get 36 minus 35 all over something. 5 times 36, 0, carry the 3, 180. 180, then there's a pi in there as well. So this would be 1 over 180 pi. And then you have to add that to the other result of pi over 36. Pi over 180. And then, multiply top and bottom here by 5. Looks like you're going to get 6 pi all over 180. And of course, it's just pi over 30, which seems like a funny answer, but let's see if it's right. Oh, yay, I got it. All right, so there it is. Hopefully that makes some sense. It's basically just cutting this into 2 regions, handling each region separately because the height function in the first region is a constant of 1. So no matter where you put the rectangle in that first area, that first region, its height, which is the distance from here to here, that height is constant. It's always 1. But in that second region, the height of those rectangles is variable, and it's because of that 1 over y function. Okay, so as you get closer to region 1, it gets bigger and bigger. As it gets far away from region 1, it gets smaller and smaller. So it's variable. It's dependent on y, in particular 1 over y. But for the height, then you have to subtract away this huge gap in order to get things to work out nicely. Okay, so hopefully that alleviates some of the mystery. Send me another message if anything is unclear. Other than that, I hope you have a good day today. As usual, get a hold of me if you need anything. I'm happy to help. That's sort of my job. Within reason. Yeah. So, okay. I'll see you. Bye.